All right. Hello again. Now we are going to talk about list. Okay. We are going to talk about list. It is important tool for our program. It is needed. Let me just switch to other camera. This list is the basic, but later on, maybe in algorithm complexity course, if you are going to take it, you may see some more details about this list. But basically, I will tell you what to do with the list. Okay, let us remember about array. It is important. And after that, we will carry on about list. What is array? Remember this. For example, we have an integer value. And we put here these special brackets saying that it's an array. And we say here a is equal to new integer. Now this part is important. We put here, for example, 5. So what's happening here when you say 5? You are creating an array which has 5 values in it. If you make it like 50, it has 50 values in it. If you make it 500, it has 500 values in it. It will be 500 values in it in array. In other words, look, there is no assignment yet, but in RAM, this is our RAM. This is our RAM. You started with A, and you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it has index 0, 1, 2, 3, 4. You see, these are the index numbers of the array, and these are the place for A. So then look at here, it is integer. Because it is integer, all of them has 4 bytes. 1, 2, 3, 4, 5 of them. In total, 20 bytes. Okay. 20 bytes of area for a variable is occupied. Okay, so in other words, in RAM, you blocked 20 bytes area. This is for 5 numbers we are talking about. If you make it 50, it's going to be 200. If you make it like 500, you are going to make it 2000. If you make it 5000, it's going to be 20,000. In other words, 20,000 bytes means 2,000 kilobyte, 200 megabyte, 20 gigabyte. Look, for 5,000 number, when you create an array, integer A, you are creating 20,000 bytes. So then you are just closing, you are occupying. Even if you have value inside or not, doesn't matter. You are occupying that amount of area, that amount of RAM from your main RAM. Okay, so this is what you are doing. After that, you say A0 is equal to 7, for example. You say A2 is equal to 3, for example. What happens? A0 is here, it is 7. A2 is 0, 1, 2 is 3, it is here. What about the others? They are all empty. Okay, but it is also allocated in RAM. It's just blocked in RAM. Nothing else can use this area. It is blocked. Okay, so when we carry on about list, it's generic collections. What are we going to have now? We are going to have a special keyword which is called list. So when you say list, this smaller than and greater than. Okay, less than, greater than. Between those two special characters, you put the data type. What data type? It can be string, it can be an object, it can be a variable, kind of, any kind of class. It can be integer. What do you mean here? You mean here you are creating a list, and you are going to put in this list integer values. And the name of list is A. Look at here, it is similar to here. Integer A, but this time you said not integer A. You said list A. What is this? You are saying that in A there will be integer values. Okay, equal to, of course, again same, new list less than integer greater than, open close parentheses. Okay. Like a constructor, like a class you have created. What's happening here? What's happening here? You created an A and there is no number here. Look at the difference. You created an A and you put here a number. You have to put here a number. Without number, you cannot carry on. And you cannot put here a number. If you put number, you cannot carry on. Did you understand the main difference? First difference, for array, you have to put number. For list, you don't have to put number. You don't put number. Okay? So, the difference between list and array, when you create array, you allocate it, you block the area, you block the memory. But here, you have just created in your RAM, a space for A. Okay, this is the point. Saying that it is list, saying that you are going to put here integer values. What does it mean? So you cannot say like array A0 is equal to 7. You cannot say A2 is equal to 3. What you should say, A dot add, in parentheses, we are going to add something now, for example, 7. Okay, what happens now? Here they put 7. I mean, it puts 7. How many area? It is 4 bytes area. Why it is 4 byte? Because it is integer. Okay, so in 4 bytes from A, you add 7. After that, A dot add, you add 3. What happens? You put 3 here, another 4 bytes. Now question, for this A, for this list, how many value do you have in the memory? 1, 2 only. But here, how many value do you have? You have again 1, 2, but in RAM, you occupied 20 bytes. But in the list, if you just put some value, you occupied only those 2 value area. Okay, only those 2 value area. Otherwise, almost everything is the same. But if we are using like big numbers like 5,000 or 500 or whatever it is, to not occupy a lot of RAM in our RAM, we are not using array. We are using list. List is better. Okay. This is the main difference in general. And what are we going to do? We are going to add another numbers if we want to add into A. For example, A dot add, let's say 4. Okay, we will try this one in the class, in laboratory as well. So then what happens? 4 appears here. Okay. So this way we are just adding the numbers. Why they are numbers? Because it is integer list. We are adding numbers into a list. Okay, so but of course if we talk about list, for this list we have some special functions, special methods as well. Logically how it works, for example, if you say here this is an array, I mean this is a list, when you say add 7, 7 appears here. When you say add 3, 3 appears here next to it. When you say add 4, 4 appears here. And you must not forget that, these have 0, 1, 2, these are the index. Okay. So in other words, after you add those numbers, when you say A bracket 0, what is this? It is 7. If you say A 1, what is this? It is 3. Okay, this is how it works in list. Because there is an add in the list, what you can say as well, for example, if you say a dot remove 3, what is this? You are just removing 3 from the list. So this 3 will disappear. So another way of, pay attention here, another way of logical view is going to be 7 here, 4 here, because 3 removed. So look at here, you occupied only 2 places. Okay, 4 plus 4, 8 bytes. This is the main difference between array, because you don't occupy, you don't delete the value here. 5 means you have like 5 value here. They can be null value, there can be nothing inside, but at the end of the day, this 5 value occupied in the RAM. Okay. To add, okay, 51909. To add your friend into lecture, he or she must join to lecture. The one who joins, we add everybody in the lecture. 51909. Okay, you understand the remove as well? Okay, what else we can do? What else we can do? It's also good to show. It's also good to show. You can use, for example, sorry, let me show here. You can use a dot remove at. You see there is remove here and there is remove at here. Okay. When you say remove at, let's say 0, what's that? This is the index number. Whatever you have in the 0th position will be removed. Okay, so new logic here. After you remove 7, only 4 appears in the screen. In the memory. Is that clear how you use it? Okay, so from there, I'm just going to repeat the numbers again. I'm going to repeat the numbers again. Here, let me write. We have a list integer. Okay, and I say a new list integer open close parenthesis, and after that for this a I'm going to add a dot add 3. I add 3. A dot add, I add 7. A dot add, I add 4. A dot add, I add 5, for example. Okay, so after that you can understand easily. Only 4 values, which are 3, 7, 4, 5 appears on the in the memory. Okay, positions are 0, 1, 2, 3. What am I going to do now? I'm going to use a special word, which is sort. It's a void method. You are just going to call it. What is sort? What is sort? To sort out this one, simply 3, 4, 5, 7. This is what's going to happen. It's going to be sorted according to numbers. So then 3, 4, 5, and 7 is going to be in order. When you try to say A0, it is 3, A1 is 4, A2 is 5, A3 is 7. This is how it works with the sort. And there is one more thing. For example, a sum. It's an integer value because of this integer. You can say like t is equal to a sum. So sum of these numbers is going to be assigned into t. So it's simple. It's very same code. You can use it in array as well. But basically, this is how it works with the list. This is how it works with the list. This is the logic how it happens. In the collection, you can put some objects, some variables, any kind of data types like double, integer, string, some kind of class. For example, you may remember we have class building. Okay, and we created something here, for example. And what you can do from this building, you can create, for example, building house, and after that You can, yes, up to data. We cannot do descending order, normal order. And after that, here in the list, you could say list building. What's happening? You are creating a list by using building. Let's say B, new list building, open close. What does it mean? You are creating buildings. And after that, B dot add, for example, building house, you said, and you add house. So then one house in your list. Okay. You could say B dot add. You could say, for example, office. But before that, you must create building office. Okay. Building office. You created an office. You remember the building, that's why I didn't go details. You remember how to create a house. Building house is equal to new building. Building office is equal to new building. That's why I didn't write it here, but you remember this one. That's why I felt this way. That's why I just write immediately this way. And in my building list, I have house, I have office, I can have something else. All right. So as you see, it doesn't need to be only integer. It can be building, it can be some other class, some other struct, some other data type as well into list. Okay, so this list is called like collection. And again, as I mentioned, this list can be used as look like an array, and the values are the look like an array, like A0, A1, A2. It carries on like this. So this is how it works. Okay. So for now, I'm going to stop because this list is going to be enough. In the afternoon at 12:30, we are going to start laboratory. And as I mentioned, after we record the laboratory part, after I record the laboratory part, I'm going to upload it to YouTube. After I upload it to YouTube, I'm going to share it with the Platon. And the one who couldn't attend my laboratory, or the one who wouldn't attend to my laboratory, must connect from Platon. Don't forget, from Platon, because in Platon I can see that you just watched that course. Okay, this is going to be attendance for you. Okay, for the laboratory part. For the laboratory, of course, we are going to have Kahoot, because we have normal laboratory course. We are going to have normal Kahoot, but for the ones who has some other classes at the same time, some other laboratories at the same time, may not join to my class. For them, it's going to be available in Platon. Watch it from Platon. This way, I'm going to see your attendance. All right. So now I'm going to stop recording. First of all, after I stop recording, yes.